Anyone can be an electronic engineer. Hello, welcome to Lastly channel. I'm Mr. Professor. You may have noticed hard drives have not evolved from traditional models like this to the high-speed version. The drying effect of a hard drive is achieved by blowing water away with the airflow rather than simply patching the hair with a high heat. This increase in speed makes a noticeable difference. The difference between their rotational speed is significant: 20,000 revolutions per minute versus 100,000 RPM, resulting in very different airflow experience. The reason is that high-speed hair dryers are equipped with more advanced, complex brushless three-phase motors. However, the traditional uses a DC motor. Today, we are going to teach you how to design a hair dryer. First, we will show you the difference between their schematic diagrams. In the schematic diagram of a traditional hair dryer, alternating current is converted into high-volt direct current by a reactive bridge, which is then directly connected to the DC motor. Airflow is controlled by adjusting the resistance value in the current circuit or using an on-off switching. It is a simple structure. This is a schematic diagram of a high-speed hair dryer. Alternating current is converted into high-volt direct current by a reactive bridge. On the one path, the high-volt DC is stepped down to around 15 volts via a DC to DC converter, which serves as the driving volt to switching the half-bridge MOSFET. Then the 15-volt supply is further regulated by a LDO to produce a 3 to 5 volt voltage that powers the MCU. On another path, the high volt DC is fed into the half-bridge MOSFETs. The MCU sends the driving signal to the three half-bridge MOSFETs, which are turned on and off, powered by alternatingly UVW three-phase current. The motor runs at high speed. The speed of motor and the heating function are adjusted through the MCU-controlled key switches. As you can see from the schematic diagram, besides the difference in motor structure, the brushless motor is controlled by a dedicated motor control chip. It is a preciously upgraded control method that enables the high-speed performance of the hair dryer. The explanation video on traditional motor and brushless motor has been attached at the end of this video and in the comment section. Here I would like to share the design of a hair dryer with you by focusing on a specific chip. The model of this chip is FU6562T, manufactured by Fonteo Technology. This chip is specifically designed for hair dryer. Here is the internal architecture. Compared with a standard MCU, this chip features an architecture specially designed for hair dryer, which reduces the number of external components. There are the schematic diagram and PCB design included in this demo kit. We can replicate the demo design, and by using the reference program and the debugging tools provided by the chip manufacturer, we can quickly move product into mass production. The thyristor-based control of the heating function and the half-bridge MOSFET drive design shown in the demo schematic are well worth studying. Now let's look at the architecture of another chip. It is the internal architecture of FS9676 chip. This chip integrated externally using MOSFETs into its internal structure, which leads to a significant reduction in number of external components. As the integration level of chip increases, the overall product cost is also lowered accordingly. We just need to learn a little bit of the principle and to know how to use this chip. Nowadays, motor control chips are becoming increasingly specialized. Although products like fans, hair dryers, exhaust fan, and a vacuum cleaner all use brushless motors, the market has developed dedicated chips for each product category based on their specific operational characteristics. AI cannot always keep up with those rapid market changes, but we can help you select the most cost-effective solution available worldwide. If you need learning material mentioned in this video, feel free to leave a comment below. If you enjoyed this video, please give a like and subscribe. Thanks for watching. See you next time.